All right, good afternoon, good morning again, everyone. We're going to go ahead and get started. If people straggle in a little late, that's okay. But we do want to get started. We're conscious of your time here. We are scheduled to go from 2 p.m. Eastern Time to 3. We envision this to be about 45 minutes of presentation with some question and answer sessions at the end. But we look forward to having you join us today to talk a little bit about dual compression, eliminating solder, and maximizing signal integrity. So just a brief overview of the presenters today. Myself, Nat Stevens, I'm the marketing manager here at Arden Concepts. And on the line with me as well is Stephen Cristaldi, our lead applications engineer at Arden Concepts.
Hi guys, how you doing? Just a little bit about my position at Arden Concepts. So some of you may have conversed with me on the telephone or in person even. My key role here is I want to come out and understand everyone's applications at a more deeper level so that the products we're producing here at the factory are better suited and tailored to your application specific. So look forward to seeing me and hearing from me a lot.
Great, thanks, Stephen. So before we begin looking at eliminating solder and how Arden tackles that approach, I did just want to talk a little bit about Arden Concepts as a company and who we are and what we do. So we are a interconnect company. We make connectors and multi-coax and coaxial cable assemblies, as well as compression sockets. Everything we do here is compression mount, and that's a lot of the technology we'll be talking about today. We were established in 2003, and we're headquartered in Hampton, New Hampshire. We've recently moved into our new facility here as we've expanded to make room for additional machinery and automation equipment, as well as new staff. So we're growing fast, and we're excited to provide our innovative interconnect solutions and interfaces to all of our customers. We're a leading provider of innovative interfaces up to 70 gigahertz for high-speed electronics. And that's really our sweet spot. That's where we focus our products. We believe that as bandwidth needs and data rates grow, we want to be in that realm to provide innovative solutions to our customers. So kind of building off of that a bit, one thing we like to focus on is some of our milestones and the history of innovation with our company. We're the first 70 gigahertz plus solderless compression mount multi-coax connector down to a 0.8 millimeter pitch signal-to-signal. We have some patented contact sets, so our RC spring probe wire form, and all our subsequent contact technologies led us to over 20 US patents filed for compliant interconnect technology. Our connectors, some of which we've used to use non-magnetic rare earth elements for use in applications like quantum computing. So as kind of theoretical and applications that are a bit in the distant future, we're still working with companies to support them in those environments. We're the first to use wire form for RF compression interconnects. We were the first to make high node count, low force, all metal interposers using wire forms. And just last year, actually, just last fall, in 2016, we launched our Quicklink coaxial connector. So continued innovation by challenging the status quo of the incumbent surface mount connectors, for example. So as a company, we're always looking for new innovation and new applications that we can support and using our contact technology and our compression mount technology to build into products that can support those applications. So our agendas for today, as we go through our presentation, we want to take a look at increasing data rates and what that means for you as engineers. And so where that's happening and what applications and what markets. We want to look at some of the engineering challenges that we've heard from our customers that they're facing and that we think they're challenges that you may be facing as well. Then we'll talk to you a little bit about, well, why Arden? We know that there are lots of connector companies out there, and we want to talk about why we think we fit the solution better. Which leads us to our solderless dual compression mount technology. It addresses really a lot of the issues that happen with solder and soldering components to your board. And we'll take a look at that, into that technology from a mechanical and electrical standpoint. I wouldn't be doing my job if at the end of that we didn't talk a little bit about the products that our technology goes into. And we'll take some time for questions and answers towards the end.
So the first topic of agenda today, it's about data rates. This is a fun slide here that we have courtesy of Intel, and it kind of shows the number of people and sort of the quantifiable data from all these large search engine and large companies that we interface with on a day-to-day basis. Basically, the drive home here is, every year data transfer rates and the bandwidth requirements are growing exponentially. Just from 2012 to 2007, in 5 years, we see projected 13 times mobile traffic. So trying to download those images to Facebook or do those Google searches or watch your YouTube videos, that's 13 times the amount of traffic has grown in just 5 short years. This amounts to a lot of data, and it requires a lot of innovative solutions. Today, most of you are familiar with PAM4 technology, so we're trying to cram more data into the same speed that we were experiencing before. So basically imagine instead of increasing the speed on the highway, we're increasing the lanes on it so we can get more traffic through. So this is a fun graphic to kind of put out there. There's lots of data. It's Moore's Law asking us to increase data transfer rates but half our cost. So in the near future, this is just going to keep growing at an exponential rate.
Yeah, I think it's just important to note that this is kind of a product of a need for high-performance computing and clean signal lines. And those will be challenges that we'll talk a little bit about down the road.
So this graphic here kind of takes us through a real-world example. On the prior slide, we talked about some of those places that we're all familiar with. Here we're going to kind of take you through a fun little graphic as an end-to-end example. So there's me. I'm on my high-end smartphone. Maybe I'm searching Facebook. So many of you in attendance here, you might work on chipsets for high-end smartphones, memory module chipsets, the actual processing chipsets, so on and so forth. And I'm sitting there searching Facebook. And that data needs to come to me over a wireless network. The current speed 4G, we're looking at next gen 5G. That's that wireless high-speed data transfer. I got to get those videos and those images to my phone at a quick rate. And it's not just me, it's millions and millions of connected users trying to get this information all in real time. But where does that information come from? We have data center networks, located mostly in Silicon Valley, these data center networks. This is what houses that information. And predominantly, we're relying on some server-to-server communication to pull on the data that I'm requesting over this wireless network. So we have servers communicating back and forth, all basically trying to get to the point where I'm looking for suggested friends on Facebook. And then at a microscopic level, inside those data center networks, each of those servers, they have their own processing architecture, and we're trying to increase those clock speeds on those processors. Because these algorithms that determine what friends are suggested to me and who ate where and who likes the clothes I'm wearing, these are complex algorithms, and we really need to be pushing the speeds for our processing units to get this done in real time. And this all affects us on a daily basis.
Yeah, and we're willing to bet that no matter where you fall on a pyramid like this, that a lot of the challenges you're going to be facing are going to be very similar, and you're going to encounter a lot of the same challenges. So what we're aiming to do is tackle those challenges. We want to help you and support you in your applications to make sure that you can get the cleanest signal, across your transmission lines and out to your instrumentation, for example.
So again, wherever you might fall inside that pyramid, we imagine that you're somewhere on this chart. So these are some of the markets and the specific applications related to these markets when it comes to our industry. So with the semiconductor industry, we know you guys, you're making the ASICs, you're making these memory modules, you're working on different types of pulse amplitude modulation or frequency modulations, and we know you're at benchtop testing all the way to evaluation boards. So we want to be there with you when we're trying to get clean signals for PAM4. We want to be there with you to support package sizes for large ASICs. And we know some of the problems you guys are experiencing with high-speed SerDes, and we want to be there to help you along the way with whatever you need, and take you out of that benchtop testing into automated test and measurement as well. So we know that during the phases there in prototyping, eventually it's going to have to come off a bench and go into an automated test measurement system, and can go from there.
Yeah, so, and beyond that, we look at things like quantum computing. Whether you're in a shielding can connector or you have cryogenic testing you're trying to do, maybe it's trying to fit a connector in a really small space. You have problems with density. For communications, you may be the folks that make the optical transceivers, but you need clock and data recovery work, or you need to characterize those transmission lines. We recognize that you come from a lot of different areas, and our goal here is to understand your challenges.
So, with all those different markets and applications, we're all design and test engineers here, and as we talked before, with these increasing bandwidths and increasing data transfer rates, we kind of stand at the forefront of pushing the technology to keep society running. So this is kind of a viewpoint on those challenges that we face and some of the most important ones. And again, signal integrity is paramount here, right? So we're concerned with attenuation, isolation, our return losses, and we want to look at all those things. And if we're doing our jobs correctly, we're gonna design for the best signal integrity possible. But also, you know, as we're designing boards, we can sit there in pen and paper and design the best system, but we're going to reach physical limitations. Some of that might come in the form of interconnect bandwidth limitations. So, you know, my transmission line might look really good, but hey, I can't get my signal off my board because nothing exists at the speeds I'm working at. You know, and that's a real problem as well. What's physically available to us. Also, for some of those in the cell phone industry and in the mobile computing industries, we have some density problems that we're trying to solve here. Where PCB real estate starts to come at a premium. So we start looking at flex circuitry and we start looking at unique ways to combat those problems with slimmer profile connectors and similar hardware. Also, due to smaller PCB designs, we have inherent routing problems. And routing problems don't just surface with small PCB designs, they can also surface with large ASIC designs as well. So, you know, when you have a really large pin map, routing becomes a tough thing to try to you know, solve, and you know, we know that you guys are facing those out in the field. Also, there's scalability issues. So we talked before that, you know, anywhere along the lines, we have guys working in the back room prototyping these products, and we have to get those out to market at an OEM level. You know, it's tough to have to work in a prototype environment and pick a product and pick hardware on there where you may use that hardware then at OEM. So, you know, it's tough if you're designing and picking a component that won't make it to OEM, because then it might not show your product in the best light as you go through your motions of trying to get that out to market. And then there's the mechanical and electrical repeatability. Some prototyping aspects, you might use a component on there to get the measurement off cleanly, but that's maybe a 1 or 2 time use item. That's never going to make it to market. In all of these challenges at the end, you know, we're all fighting controlling cost here. So none of us have an emptyless barrel of money. All of us have budgets we need to stay within. So we're going to look for those best connectors. We're going to use the best board materials. And obviously those are on everyone's big wish list, but you know, IAPW, in a perfect world, it'd be great if we could have the best of best, but we just don't have the budgets for those, so we need to be conscientious and do trade-offs between you know, real estate problems and signal integrity and what's going to be scalable to the end product. So we'll pick and choose what those best things are, but you know, these challenges affect those guys at the back of the process and at the front of the process, and what Arden stands to do is we want to make sure we can make that transition cohesive and that everyone realizes that we can, that, you know, those problems exist on both ends of the spectrum.
So why Arden? You know, you know, we make passive equipment, sockets, connectors, and cable assemblies. We recognize that there are lots of companies out there that do that. And really, the goal of a company like ours and the products like ours are to get a signal from point A to point B with the best signal integrity. So essentially, we're building the road that you travel on. So when you're sending your signals, we're the components within that system to help you kind of send those signals along with the best signal integrity. Now, why Arden? Really 3 key reasons. Our core competencies here: dual compression mount, a solderless solution. And this is what today's webinar is going to be focused on, and why that matters to you. Signal integrity is our passion. You know, we spend the time to when we're building our connectors and our sockets, we spend the time to model and simulate results and then measure them after. So we want to make sure that the information we're providing to our customers is measured data. We want to show that the connector in action and make sure that everything we claim to be true is true. And manufacturing excellence. Really an idea that our company was kind of founded on a mechanical engineer pedestal, but we've expanded that mechanical engineering know-how and knowledge to then look at real-world scenarios and how we can apply our connector technology to your needs.
So, our dual compression mount technology. You know, when we talk about compression mount technology, you know, what do we really mean by that? So by compression mount, you know, we think it's a form of technology in which the electromechanical contact between 2 components is achieved through compressing the 2 mating faces. Predominantly, you guys, you know, you're going to see this used when interfacing a device to a PCB, a printed circuit board. And that device can either be the device under test, like the integrated circuit, or it could be, PCB board to PCB board, in which, one's a mother card and a daughter card. But, what's unique about Arden solution? So we call it the true dual compression mount. So, some of you might be familiar with pogo pins. And, pogo pins, they come in either a compression mount style, but sometimes one end must solder down to a board. For this case, I'll refer to that as single-sided compression. So it's important to differentiate the two because none of Arden's products get soldered down ever. We're always compression mount on both sides. So, you can see on the graphic in the bottom left, there's a pogo pin, one side soldered to a breakout board, and the other side's the one that has the compression on it. So, when we get into another slide, we'll talk about, the problems that can occur from that type of mechanical solution, and electrical problems that can occur from that as well. On the right, you see the Arden contact. There's no solder joint on either end. This is actually a cross-section of a contact in situation being used, and you can see it's compressed on both sides. Again, no solder joint either end. That's the philosophy of our technology. That's through all of our products. And we're going to get into the next slide a little bit about why that's different from solder solutions. So some of the concerns with solder, right off the bat, is solder contamination. So in a perfect world, we'd have a nice clean environment when we solder our connectors on, but I have seen, and it is a real problem where, foreign objects and foreign material can get in there and there can cause some contamination. If the flux is not applied correctly or if the wrong type of solder is used, incorrect material composition can lead to degradation in signal integrity, as well as rapid forms of failure modes through oxidizations and those types of chemical breakdowns as well. Also, we've all been subject to poor solder joints, and this can really rear its head in a couple of different ways. Sometimes we'll chase electrical problems not realizing that it's a solder joint, and we try to debug along a trace, looking from the duct to the test equipment, and I've seen the problem where we're looking to make sure our test setup is correct at the VNA level, and it's really a poor soldered down SMA connector. So that's very important, and you can spend a lot of time doing that. Also, once you isolate a poor solder joint, there's reflow issues that can occur when you put a board back in an oven. It's not guaranteed that other components on the board aren't going to come dislodged or something like that. You run more chances of those boards warping the more time they spend in the ovens, and so on and so forth. And of course, there's downtime. So this, time is money. Of course, with solder, there is an environmental concern. People are still using tin lead composition. That's toxic to inhale. It's not really good for the environment. So, our little nod to the green is we eliminate those environmental concerns with some of the solder uses. Board respins are costly too. When we're talking about people in the evaluation board market, I know on occasion we'll go through 5 different revisions before a board actually makes it out to market. And when you have a surface mount technology connector that's soldered to board, every time you respin a board, you're probably just junking that board, and you have to lose sunk cost basically into junking those connectors with it as well. And then again, broken connectors. I don't know how many times I've tried to screw down a patch cord to an SMK style connector and break the pin off or break the solder joint. And that's on my head, but now I got to go find somebody to repair it in-house, and if it can't be repaired in-house, I'm making a new board. So again, time is money. The big picture here with some of these concerns are it's increasing our time to market, it's money lost. And again, as I talked about before, we're always cost sensitive when we're designing our components, and we want to be careful of that. So this is a unique slide to just talk a little bit more about Arden's compression mount technology. In the top left, we're kind of showing a typical cross-section of a pogo pin design, and I'm sure many of you are familiar with it, but just to reiterate, you can see that there's a cap to the pogo pin, there's some sort of a spring providing some compliant interface, and then there's usually a lower portion as well, which is then soldered to the board. You can see Arden's first approach at a solution to that, which is this wire form here in the center, and that's actually one of our initial patent drawings, of which we hold over 20+ patents, which are all pertaining to compliant pin technology. And then in the final design, you can see our model of the spring probe contact in the bottom right. So, some of the problems that are inherent with the pogo pin design, for example, is, there are more mechanical moving parts, which means that there's more failure modes available to you inside in that design, and that's all related to mechanical reliability. Also, one of the issues as far as electrical performance and repeatability is concerned is, the pogo pin may not always short the way it's designed to short, and that can appear as opens, or it can appear as resistivity changes, and that's not a good thing either, because now you're chasing solder problems as well as a problem that could be inherent in the pogo pin design itself. So just want to kind of show that. Also, it's worth mentioning here, our CTO and founder, Gordon Vinter, he was a designer of pogo pins. And, the inception of the wire form that you're seeing here on screen, that was his brainchild, because he thought there has to be a better way to make a compliant pin technology to avoid all the pitfalls of pogo pins and solder down solutions. And, that first patent drawing, I mean, that paved the way for our technology. That paved the way for what we're going to continue to talk about here. And it's been in our philosophy ever since. So this slide, it's a neat little slide to kind of get you guys to understand how our compliant pin technology works. On the left, it's the newest series is our ladder contact looking type device. It's called the CR series. And on the right is our legacy, our spring probe style. Now, you can see on the right the spring probe. It looks like a kind of a coil, but you can see they're all compressed together. So the unique solution that the wire form brings to us is, when the item is uncompressed, for example, those wire form coils, they're slightly open to each other. And when you compress it together, when you put a device under test, or when you put a board-to-board connector together, those tend to wipe against each other. And that provides a unique advantage over preventing oxidization. So when they start to wipe together, they'll remove any outside oxidizations layer and create a clean signal time and time again. So one of the big reliability factors of this is you'll look at our wire form, and from start to finish, and when I say start to finish, I mean from day one to when mechanical fatigue failure causes the pin to completely disintegrate, resistance doesn't change, basically, which means you'll get the same signal integrity from day one to the day the mechanical failure happens throughout the device. And this is important because a lot of customers are used to seeing resistance change over time through use. This does not happen with this device. On the left, the wire form, the ladder type contact. When this one compresses, it sort of rotates a bit, and on the top and bottom, it provides some scrubbing action to reduce oxides as well.
So it's important to note that these two contacts that you're seeing here, some form of these are going to be in every Arden product that we sell. That's important to know, because basically what we did is we found the right recipe, and we use that recipe in all of our products, whether it's a socket, whether it's a board-to-board connector, whether it's multi-coax. We're going to be using our patented technology in any of those products.
So just to reiterate, we started with the design on the wire form, that's the spring form. Then we developed a ladder type contact that you can see here as well. The point of this slide is just to get you guys to understand that, depending on the application, we developed a unique solution to it. And as Nat had mentioned before, manufacturing excellence, we do have a league of mechanical and electrical engineers here, and we're marrying our understanding of mechanical processes to basically innovate the market with contact solutions that didn't exist before through our stamped ladder type contact, and also our wire form as well. So we're kind of bending and shaping our IP to fit certain applications down to small pitch, down to large pitch, down to different stack heights, and so on and so forth. And we're conscientious of mechanical requirements there, as well as signal integrity requirements. So, these next slides are going to kind of talk to signal integrity as our passion. So, we know we have a good mechanical contact. It's been through its paces. It's been proven. But, it's now getting to the time where we want to show our prowess in electrical engineering. So, we pride ourselves. We have the best versions and the latest versions of electrical mechanical simulation software, or HFSS software. What we do with most of our designs is we prove them out first. Not most, all. We prove these designs out with modeling software, and we try to get the best prediction of where our product's performance is going to lie. Then we can rapidly produce through an R&D quick turnaround, and we produce that product, and then we test it, and we compare real measured results against our simulated results, and we can go back and tweak designs in real time. So this design here showing on the board, you can see the perfect model that's been drafted in the red line. You can see our preliminary measurement from our first R&D prototype. And then the green graph shows our tweaked model with our new measurement. And we continue to do this in real time, and we're continuing to innovate our products and make them better and better and better. So we can assure that the final product that we release to the market, it's always based on measured data, and it's always based on what the best we could offer is. I don't know why. One more. And again, just to reiterate, we have invested a lot of time and money into the proper software through, we use ANSYS primarily, but also the equipment too. So, we pride ourselves on having both a 40 gigahertz and a 67 gigahertz PNA, and that's really important. And soon to come is going to be a 100 gigahertz PNA. And, for some of you out there, I know some industries don't even have 67 gigahertz PNA. And what this amounts to is Arden's trying to be at the forefront of high-speed, high-bandwidth technology, so that when you get there, you might not be there today, but when you need a 70 gigahertz solution, we're already working at a 100 gigahertz solution for you, and so on and so forth. So we always try to stay a step of the competition and a step of your needs as well, so we're experts by the time you get there. So a lot of time and effort into our measurement setups and our measurement products, and we try to be experts in that area. So again, I wouldn't be doing my job if I didn't spend a little time talking about the products that Arden makes and where all this great technology goes and what it gets put into. And from a product standpoint, we really have three product families here. We have our multi-coax and coax cable assemblies and connectors. We have our connector division, CA series, which is essentially things like board-to-board connectors or optical engine connectors. And then we have compression sockets. Again, leveraging that compression mount contact technology that we've talked about in the past few slides. So from a product standpoint of our TR multi-coax series and our multi-coax connectors, TR multi-coax is our product that delivers superior signal integrity from multiple high-speed analog or digital channels. We offer it in a choice of 20 gigahertz, 40 gigahertz, or 70 gigahertz flavor varieties, depending on your bandwidth needs and the applications you're working on. And users can upgrade those connectors as their bandwidth needs grow. So again, as Stephen mentioned, as we look out past 100 gigahertz, for example, we're constantly looking to develop a newer version of our multi-coax connectors to support that for an application, for example, like automotive radar. So TR is the highest density high-speed multi-coax connector on the market. The interface is compression mount using that same technology we talked about to drive down lower total cost because you don't have to solder down any of those surface mount components, things like SMAs or SMPs. And as you build up more complex boards, you may have 10 or 50 or 100 of those SMPs on the board. That takes up a lot of PCB real estate and frankly, a lot of test time and a lot of engineering time as you're working to mate and demate those connections. With our solution, with our TR multi-coax series compression mount solution, we offer you the ability to quickly connect and disconnect multiple channels of high-speed signaling. So some of the benefits here to take a look at. Superior signal integrity up to 70 gigahertz. And actually in the handout section, which you should be able to access on your GoToWebinar panel, you should be able to download our data sheet, which will show some of those measurements and measured data for insertion loss, return loss, and crosstalk. Better long-term repeatability of connector performance. So we say that our connector is good to at least 1,000 mechanical cycles. When we look at things like an SMP or an SMA, we're hearing from our customers that they're lucky if they get 50. So repeatability, being able to use that connector over and over again. Here's the key piece, a solderless system. So it's eliminating that signal distortion, and you're getting better signal integrity with a better mated connector. I mentioned it in the description, but quick connection of multiple signals to your PCB on a very, very small footprint. So about 80% space savings over things like SMAs. High density, you're getting closer to your device under test. So as you're trying to get a signal from a device that you're working on or testing and prototyping out to your instrumentation, we know that signal traces can be lossy. So the shorter signal trace you can get, the closer you can get to that device, the better off you are. And no more failing of snapping connectors. As Stephen mentioned, you're going to screw an SMA to the board and that surface mount connector snaps off. That's wasted time. That's wasted resources. And so we don't have that issue with something like our TR multi-coax connector. And really key, I think, amongst all of these,
Our product's reusable across programs and promotes exponential cost savings. So there's no solder down piece. It's just artwork on your board. So a symbol, and we'll probably talk about that a little bit more. But it's a symbol on your board, and that's it. So when you go to lay out a new PCB design, you can just put that symbol on and bring the connector with you. Our latest product release that we'll actually be featuring at DesignCon coming up, and we'll give you our booth number as well for that, is Quicklink connector. And so our Quicklink coaxial connector is a single mode or differential mode compression mount coaxial connector. It requires no screws, so it's a twist to lock motion, and it's a quick way for you to access signals and from your device under test out to instrumentation. So areas where we're seeing Quicklink use would be something like an eval board, where you have lots of signals that you want to be able to probe and take a look at, but you don't want to ship multiple connectors with that board. So you could place a Quicklink footprint anywhere you want on the board. You could put 50 on a board if you wanted to, and just move that Quicklink from one to another. So it's a kind of a quick reusable singular differential probe version of the Quicklink.
And again, as Nat had said before, just like the TR device, the Quicklink product itself lives in itself, which means on the board, all that's required is that gold-plated footprint. So when he's saying, you put 50 connections on the board, they're just 50 footprints on the board with no leave-behinds and nothing else. So with just one Quicklink cable assembly, you can probe all those 50 points. Think of it more like a single patch cord replacement to a SMA, SMK, or 1.85 millimeter, only the advantage is there's no connector that's left down on the board. And at the high speed capabilities, those connectors can be pretty expensive, especially over multiple board revisions.
So our SK series compression sockets, this is really where our company was founded and the space that we started in. We understood that making a better socket, a higher performing socket, was important to our customers as they went through development and test of their chipsets. And so engineers in the test environment, they're focused on sockets that offer high performance at a lower cost. And Arden's compression contacts and compression technology allows you to lay out those footprints for the sockets on your board. And if your package size changes, you can maintain that mounting and tooling on your board and get a new compression socket from us. So you could remove the old one and put a new one on. So for board respins and things like that, you're not just throwing away the board and having to spin a new one. You can actually just maintain, get a new socket from Arden. So some of the benefits there, that compression mount. It can be easily mounted and demounted with just a few screws. So there's nothing soldered and no sunk cost. Bandwidth and performance. They're multi-gigahertz VGA socket solutions. They offer low loss for things like wireless devices, processors, FPGAs, high-performing devices out to 40 gigahertz and beyond. And right now where we're really focused and spending a lot of time with our sockets is in the 32 gigabit per second optical area. So optical transceivers and CFP modules needing to get out past that 28 gigabit to the 32 gigabit bandwidth. We've heard from our customers that that's been a struggle for them, and our contact technology allows us to get to those bandwidths and to help those customers, really solve their bandwidth problems and their signaling problems. Cost savings. So we offer things like Stephen showed you our CR contact, the laddered contact set that we looked at a little bit earlier. That stamp contact set is available for OEM applications. So it's a stamp contact that we can load into an automated machine and quickly and rapidly build out these sockets and connectors to be reused on multiple board and IC revisions.
Yeah, a key application for the compression mount socket, and one of the ways that it really shines out. Nat had mentioned reusability. So we know some customers are moving to standard form factors, meaning the ASIC package dimensions are the same and the number of nodes in the package is the same. Now within that, I know the ASIC developers, they'll change their ball maps and their pin maps to what suits their need, but the fact is you've standardized on a size. So the nice thing is, when you get a compression mount style socket, regardless of the board stack up and the board design changing, you can pull the socket and move it from project to project while you're in your bench and test measurement. And again, with the scalability of options between high performance, high bandwidth types of contact sets, and then a more OEM contact offering, you could always actually modify the socket assembly from what you already have, use the same footprint, and then go from a high speed, high bandwidth test and measurement side, same footprint, into an OEM type application later on down the line. So very powerful when it comes to reusability in that aspect.
So our CA series, connectors and interposers, kind of follow along those same guidelines as the socket where we're populating an insulator with our contact set. What's really nice about these is they're customizable, they're low profile, and offer you an area array down to 0.4 millimeter pitch. They compression mount all of them. So if you're trying to mount board to board or chip to board, you know, you're able to do that with a few screws. It's a purely vertical interface, so there's no offset required, unlike some connectors out there. Bandwidth and performance. I mentioned that, you know, we're now working out in that 32 gigabit and beyond space, and that twisting CA series action ensures a good electrical contact every time. Cost savings. So we talked more about that stamped contact set for OEM applications. So building these connectors into your end product. And so we offer a contact set in that environment for 1,000 cycles, but we offer one for 10,000 cycles as well, depending on your use case.
Yeah, you know, Nat had mentioned the bandwidth and performance of the CA series, and in specific, we'd like to talk about that OEM CR ladder type style contact. You know, as of recent, for board-to-board connectors and the likes of, there are bandwidth limitations, and as we move forward and we try to design our systems for increased bandwidth and data transfer rates, we know, especially in the digital side, that having a limitation on the amount of gigabits per second, that can be problematic. So, you know, we're really proud of that CA series because being able to achieve 32 gigabits per second, we're talking about mode free here. So there's no clock retiming that needs to occur. There's no passive equalization or amplification that needs to occur. And, you know, what we think this amounts to is when you're designing the circuitry to test that device, instead of having to compensate for lower performing or underperforming connectors on the board, in this case, you don't need to include any of that extra circuitry. You can go right from DUT to measurement device without any of those expensive circuitries to add in.
Yeah, and I think this is a good opportunity and a good example to talk with our CA series about kind of how industry standards just don't necessarily keep up with the applications that you as engineers are working on. And so for an example for our CA series, we know that lots of you are probably using the FMC connectors, the FPGA mezzanine card connectors to connect one of your PCBs to another. Maybe you're working on something like an analog to digital converter or an optical engine, and you need to connect those two boards. We're hearing that the limitation of those connectors is 28 gigabits per second. Up until now, that's probably been good enough, but we're hearing that applications are starting to need bandwidth beyond that. And so, you know, creating a drop-in replacement FMC style connector is something that we've been able to do to provide you with that increased bandwidth and that support. So,
and some of you that aren't even at 28, some of you might not even be at 12 gigabits per second. The point is Arden's there at 32, and we're going to be there tomorrow at 56. And by the time you get there, you can rest assured that our product and our technology that you want to use in your application, it's tried and true. And we'll have already gone through the trials and tribulations to make sure that when you're using our product, we've been there, we know your problems, we know your situation you're up against, and our product is going to be performing as described.
Yeah, and so essentially, I mean, that's essentially what our goal today was to take a look at is you know, why we differentiate ourselves from other connector companies out there in our technology, and then how we use that in our products to support your needs for growing bandwidth and data rates. You know, that's the fun part about our jobs here at Arden is tackling the challenges that you're facing, working with our connector technology to be able to support your latest applications. So as you bring problems to us, we work with you to solve them. You know, so we really like to think that we're partnering with our customers as opposed to providing them a solution. Right. So with that said, we'll take a few minutes now to look over some questions. We've had questions filtering in through the questions box on your GoToWebinar panel. We encourage you to submit questions now as well as we start to go through and answer some of these questions. So feel free to submit some questions. I don't know that we'll get to all of them today, and if we don't, rest assured that we'll follow up with you in regards to your questions and make sure that we get you the answers you need. So let's see. I'll just kind of pick and choose from random to be fair here. But the first question here, Stephen, for you, what type of plating is required on your footprint?
Yes, this is a good question. Considering all of our technology is compression mount, mostly we rely on just the footprint on the board. So this can be kind of a criticality for those of you using any of our products. Coming from a socket industry, which is really where we got our start, we say by standard hard gold over nickel. That ensures longevity of both the PCB and the Arden connector itself. However, as times change, we know you guys are using ENIG and ENIPIG. Our product technology works perfectly well with those with no degradation to signal integrity. The only caveats there is really what you'll see with the change in plating is how long that board will last. And you know, the technology, the Arden side of technology, it's going to still last up to the number of rated cycles no matter what the plating you use, and it will still perform to the signal integrity specified.
Great, thanks. Next question, if your products are compression mount, how do they secure to the board?
Yeah, sure. So we showed a couple of sides of the sockets and of the TR. For most of the products, the sockets and the TR, they'll screw down to the board. With the sockets and with the TR device, we supply them with what we call the board stiffener, and this has been designed to press into the underside of the board, and it provides the tapped holes, and the TR device screws down to it. What the stiffeners provide is mechanical rigidity for the board, as well as those mechanical tapped holes for the product to screw down to. However, some of our products, the new Quicklink and the new TR quick latch device, they actually just latch down to the board, and they don't require any board stiffeners underneath or anything. It's all done through the mounting holes that are routed into the board. So in the case of the quick latch, it's a push down and quarter clockwise turn to lock it in place. And with the quick latch TR device, it's simply push down and latch onto the board.
So I think it's important to note that as we review through these questions, lots of the questions that we're sure you'll be asking, we actually have answered in our application notes. And so that's something that if you have questions, we can provide you with a series of application notes to help walk you through a lot of these questions and a lot of the answers that we provide. So we'll continue to look at that for you and update those. Yep. So another question I have here, I've used your product before and noticed filled and plated via requirements. Can you elaborate on that?
Yeah, so some of our TR footprints in particular, they've asked for filled and plated via requirements. So due to the way that the TR contact lands on the board, it basically lands directly in center of the signal pad. So for those in strip line routing, we do need the via to be filled. However, it doesn't need to be filled with a conductive material. We just ask for non-conductive epoxy. This is really a limitation of the mechanical design and not signal integrity related at all. So you know, when you see that there, don't be afraid of it. It's non-conductive epoxy filled, and it's really just for mechanical usability. We have another question here. Is there a range of PCB thicknesses supported for the Quicklink? Yes, there is. So the Quicklink there's referring to is the push down and quarter torn lock that comes in the single channel and differential pair. At current, the Quicklink has been designed to work natively with up to 100,000. So we say from 60,000 to about 100,000. If your board's thicker than 100,000, the only requirement we have there is on the back side of the board, you can do a simple counterbore, and that will provide the lip for the latch to lock into. So really, there's almost no limitation. The minimum board thickness is 60 thousandths. The maximum board thickness, no limitation. It's all about how you put those mechanicals in. And our footprints will spell that out for you. And of course, if any of you have questions outside of that and into something specific, we do have a channel for that as well.
Great. So another question here that came in, will any or all of your products work with microstrip and strip line boards?
Yeah, very good. I know some products out in the market will only work with one or another routing style. So by microstrip, of course, we're referring to the strip on the top trace, either you know, coplanar waveguide, so on and so forth. In strip line, we're referring to when the trace is internal to the board. I know some people call it different things. I just want to be explicit here. All of Arden's products will work in either scenario. The TR, the sockets, the Quicklink, the board-to-board connectors, they'll all work with microstrip or strip line. The only caveat to remember here is when you get into smaller density or smaller pitches or larger node counts, routability is going to be an inherent problem in your design anyway. So it's something to consider. You know, microstrip might be really hard at a really tight pitch with really a lot of node counts. You might have to move to strip line. But the Arden product, it doesn't lay credence to either one of those. Will work in either scenario.
Great. So I have a question here. Can you expand on how TR can save cost compared to surface mount components? And I think this is a question we get a lot. And really the concept here is, again, there's no sunk cost, and it's the point that over board spins and over programs, you can reuse that connector, the TR connector, over and over again, whereas typically you're just discarding those SMAs or SMP components. So you may have 20 or 50 on a board, and at anywhere from $10 to $50 a piece for those surface mount components. you're discarding a lot of money with each board that you toss out and respin. With Arden's products and just the PCB symbol, that footprint, you can bring that connector with you from board to board. So it really starts to add up very, very quickly as you move across programs and across board revisions. So I think that we're about out of time. As I mentioned, if there are additional questions that you have, we'll make sure to follow up with you. And if you have additional questions beyond what you saw today, feel free to reach out to us. We're happy to work with you to answer all your questions and to look at any applications that we might be able to support. Up on your screen now, you have access to our sales channel and our technical channel as well. So feel free to email us at sales@ardenconcepts.com or reach out to our technical team at support@ardenconcepts.com. And we want to thank everyone for joining us for today's webinar. As we mentioned, this will be recorded, and so we will be able to send out this webinar to you, and you'll be able to download it from our website as well. So feel free to do so. We hope you'll join us for future webinars, and with that, we hope you have a great day, and we'll talk to you soon. Thank you very much, guys.
Bye.